Yo, hey everyone. I'm gonna make another mock interview. Okay. Oh, this one's an easy one. Remove linked list elements. Remove all elements from a linked list of integers that have value val. So, given a value, just remove nodes that have that value in the linked list. Okay, so I'm thinking I'm pretty sure I can do this in one pass. Yeah, I can do this in one pass. Now I can check the next node and then delete it if I need to, or I can check my current node and then connect my previous node to the next node. But I think it would be easier if I just check the next node, and then if it was the wrong node, then I'll delete it. Yeah, and then I can see a problem like, what if first element is dot value? Yeah, so that could be a problem, but I'll handle that test case later. So for now, I'll just go through, iterate through it. So this is doing it iteratively. I'm just considering all my options here. What if I do it recursively? If I do it recursively, yeah, I don't think it'll make too much of a difference. Alright, yeah, I'll just do it iteratively this time. So while so we first have to have a current node that keeps track of current, right? The node that we're on. We set that to head. Let's first do a null check. If head is null, then just return head. Otherwise, there is a head, and we set the current equal to head. So while head has while current has a next value, we first check if current next val is equal to val. So if current's next node so val current.next is also a pointer. Okay, if that value is equal to val, then that means we want to delete it. So current next will equal current next. Okay, and then after this, after this, we just want to continue. Or, shit. Actually, what we can do is otherwise, we move current equal to current next. So basically what I want to do is I check the next node's value, and then if it's the value I'm looking for, or the value I'm looking to delete, I delete that node, and then I set my next. So if it was like this, if this is current and I want to delete this node, then I'm going to set the next pointer to point to this node, which effectively deletes this node. But then if the next node isn't the value I'm looking for, then I just want to update and make this the current node and continue my algorithm until until I reach the end of the linked list. And then over here, I just return head. But the thing is, again, I have to account for what if the first node is the value, right? Then I want to delete. If the first node is the value, like let's say it's 6, and then it's like 5, 6, 4, whatever, then at the very end of this algorithm, it'll become 6, 5, 4. So basically, the only thing I didn't check is the first node. So I can do a ternary here, but I'll make this more clear. So I think, okay, there are two ways to do this. Either make a dummy head, like so these are the two options I'm thinking of right now. I can make this node current equal to new list node. So make a new list node, and we'll make it 0. And then I set its next pointer equal to head. So then when I start doing this, when I do this, then I'm also calculating the head as well. But then, and then at the very end, I would just return, wait, sorry, let's call this dummy head. Then dummy heads next will equal to head, and then I'll set current equal to dummy head. Do you see what I'm doing? So I have a dummy head that sets its next pointer to be the head, so that when I check current next, that includes checking the head, this head. But another way to do this is just I do all my checks, and then at the very end I check the head again, and I check, okay, if head is val is equal to val, then I want to return head next, else return head. Right, and then I think I could optimize this by doing return head val equal to val. Is that true? If it is, then return head next, else head. Okay, okay, so I'm going to, this is the rough draft of my algorithm. I'm going to go through it again. So if the head, we first check if there even is a head. If there isn't a head, then we just return head, which is null. Otherwise, we iterate through the linked list, and we have a current node to keep track of the current node that we're on, and we set that to head, which is the beginning of the linked list. Then while current has a next node, we check that next node's value, and we check against the target value. If it is, then we quote unquote delete that next node by setting our current next equal to current next. Otherwise, we just iterate through and we update current to be current's next. At the very end of this, we still haven't checked the head, so we checked if the head's value is equal to val. If it is, then we want to quote unquote delete that, so we return that head's next. Otherwise, we just return the head. One time accept, yes! Okay, I mean, that was an easy question, so yeah. Let's just see the other solutions that I talked about. Okay, so why don't we first see if this optimized ternary also works. Okay, it does. And then let's see about this dummy head thing. What? Oh. Okay, see? So, yeah, the runtime is O of n. I don't know what else to say about this. Let me know if that explanation was good. And I know I've been posting a lot of mock interview videos lately. Part of that is because I really hate, or now I kind of like don't really like preparing for interviews, so this is kind of a way for me to prepare for interviews, because interview season is coming up for me too. Yeah, thanks for watching. Let me know if there's anything I can clarify on, or if there are any topics or videos you'd like me to make. Until then, see you next time, and thanks for watching.